All right, let's pull back the curtain on one of the most powerful, yet kind of invisible forces in your digital life: databases. Seriously, they are the silent engines running literally everything, from your social media feed to your online shopping cart. And today, we are going to demystify them. I mean, have you ever really stopped to think about that? Every single time you tap, click, or swipe on an app or a website, you're creating data. And it doesn't just, disappear into thin air. Nope, it's captured, stored, and meticulously organized, all thanks to databases. So, let's start with the absolute basics. What exactly is a database anyway? At its core, it's actually that simple. The best way to think about it is like a super organized digital filing cabinet. Instead of just piling documents randomly in a drawer, a database gives you a system, a way to create, find, change, and manage information really, really efficiently. Now, databases pretty much fall into two main families. On one side, you've got your relational databases. You can think of these like spreadsheets on steroids, very structured with neat tables, rows, and columns. And on the other side, you have non-relational or no SQL databases, which are way more flexible and just perfect for the kind of messy, unstructured data of the modern web. So before you can build anything, a house, a piece of furniture, whatever, you need a plan, right? Well, in the database world, that plan is called a schema. It is the architectural blueprint that lays out exactly how your data is going to be organized and how all the different pieces of information relate to each other. And this brings us to the design itself. See, a great database isn't just about storing data. It's about storing it smartly. A really well-thought-out design is the difference between a lightning-fast system and, well, a digital traffic jam. The very first step in creating that smart design is often something called an entity relationship diagram, or just diagram for short. Think of it as a visual map of your data. It helps developers see the main components, the entities like users or products, and how they're all connected, long before a single line of code is ever written. But how do you make sure that design is clean and efficient? Well, that's where this process called normalization comes in. Honestly, think of it like the Marie Kondo method for your data. It's all about eliminating clutter to, spark joy for your app's performance. For example, the first step, 1NF, is just about making sure every piece of information has its own little spot, not all jammed together. Then 2NF and 3NF build on that, making sure you don't repeat information all over the place. So instead of storing an author's entire biography with every single book they've written, you just store it once in a separate authors table. It's all about making your data lean, logical, and way easier to work with. Okay, so you've got your blueprint. Now, how do you actually build the house and, talk to it? Well, for most relational databases, you need to speak their language, SQL. SQL, which stands for Structured Query Language, is built around a few core commands. With select, you're asking the database for information. With insert, you're adding new stuff. Update lets you change things that are already there, and delete, well, I think you can guess what that one does. These four actions are the absolute foundation of almost everything you do. But the real magic of SQL, that comes from joins. Remember how our schema defined all those relationships between data? Joins are how you actually use those relationships. You can ask for a list of all your customers and the specific orders they placed, pulling that data together from two separate tables into one beautiful combined result. It's incredibly powerful stuff. Okay, let's step out of the classroom for a second and see how all this stuff applies in the real world. We're going to go from these foundations to the massive, complex systems that run everything. Because the database ecosystem today is just incredibly diverse and it's always changing. Yeah, it is not just about SQL anymore. The whole NoSQL family has totally exploded to handle the insane demands of big data and real-time apps. This just means there are different tools for different jobs. You've got super fast key value stores for things like caching, flexible document stores for content, and really powerful graph databases for mapping out complex relationships, kind of like a social network. So, where do all these databases actually live? Well, more and more, they live in the cloud. Services from places like Amazon and Google take all the headache out of managing them. They handle backups, security, and scaling up or down automatically, which lets developers just focus on building cool stuff instead of worrying about servers. All right, let's bring all these ideas together and make it real. We're going to walk through a simple design for a library management system, putting all this theory into actual practice. First up, the design. Our blueprint, that diagram, would identify the main things we need to track. books, authors, users, and, of course, loans. And it would show us exactly how they're all connected to each other. Next, we take that blueprint and translate it into actual SQL code. We use the create table command to define our tables, and you can see how we specify each column, like title, and what kind of data goes in it, like varchar, which just means text. This right here is the blueprint becoming reality. And now we get the payoff. With our structure built and the data loaded in, we can start asking it questions. Using a select statement, probably with a join, we could instantly find every single book written by a specific author, or generate a report of all the loans that are past their due date. This is the power of a well-designed database in action. So, from a simple blueprint to a powerful information tool, databases are truly the invisible architecture of our modern world. They're what turn chaotic data into structured knowledge, and they enable nearly every single piece of technology that we use every day. So the only real question left is, what will you build with them?